In this lesson, we are going to learn how to transform objects. We already did a transformation, which was with the camera, when we moved the camera a little backward, but we are going to see a lot more, like rotating and stuff like that. We have to learn how to transform objects because in the next lesson, we are going to learn how to animate objects. And if you want to animate an object, you first need to know how to move that object. More in the next lesson. So there are four properties to transform an object. You have position, which we already seen, but we have a lot more to say about the position. We have the scale, okay. We have the rotation, okay, but we also have the quaternion. What's that? You probably know what is a position, a scale, and a rotation, but what is a quaternion? Actually, a quaternion is like a rotation. More about this later. All classes that inherit from the object 3D possess those properties like perspective camera and mesh. What I mean by that is that if you open the perspective camera documentation, so click on the link inside the lesson page, like this. If you click on this link, perspective camera, you can see that in the 3GS documentation, you can see that perspective camera inherit from the camera, and the camera inherit from object 3D, which means that perspective camera inherit from object 3D. If you test the mesh, as you can see, mesh also inherit from the object 3D. Every object, every class that inherit from object 3D has those properties I just show you, which are position, scale, rotation, and quaternion, which helps to transform objects. Great, so let's use them. Those properties will be compiled in what we call matrices. So what is a matrices? Actually, do not worry, you don't need to understand matrices to do transformations. It's just so that you know, because maybe at a point we are going to use matrices, but when you do a rotation, a position, stuff like that, behind the scene, in 3GS, you have matrices that get updated with complex code, and at the end, those matrices are sent to the GPU, and the objects render on the screen just as is supposed to look like. Okay, so this is very complex, but you don't need to understand matrices for now, at least. You can just create objects, rotate them, and it should be working. All right, the setup. As I told you, I'm going to help you set the starter so that you really understand how to use it and how to use this webpack. It's going to be quite fast, don't worry, it's easy. So yeah, you are on this page looking at this video, you scroll a little to get access to those buttons, and you click on Starter Pack. The starter should be downloading right now. Once it's downloaded, you just unzip it because it's a zip file. You have to unzip it. If you are on a Mac, you just double click. If you are on PC, you have to right click and something like this. I don't know exactly. And you get this folder. So as always, it's the name of the lesson with 05 because it's the 5th lesson. Okay, you can start from here. You will have to open the terminal inside that folder, but what I'm going to do is move those files in a more appropriate place, which is for me inside this folder, which is transform objects, because it's how I organized my folders, because I have a lot of more files. Do as you want. So now that I have my starter files unzip and available here, what I need to do is open the terminal. I'll be using the Visual Studio Code terminal. To do that, I can use the shortcut, but if I don't know the shortcut, I have to press View, to click on View, and then choose Terminal, as we saw in the previous lesson. Doing this will open the terminal. So I have some stuff written here, but you can clear it. You should have something like this, with the name of the folder here. If you are not in the right folder, you have to be in the right folder. So you have multiple ways of doing it. You can do CD space, don't forget the space, and drag and drop the exercise like this, and then press enter. So right now I'm inside the right folder. Or you can open this folder inside VS Code. And to do that, you just have to drag and drop it. See, I'm drag and dropping, and I'm dropping it inside Visual Studio Code. The color changes. You see the viewport color changes. And that's it. The Visual Studio Code is now open on the right folder, and you can see the files inside that folder on the left. If you open the terminal from this Visual Studio Code that you have open in the right folder, it will be automatically on in the right folder, which is another way of doing it. Now that your terminal is inside the right folder, you have to run npm install. You just have to wait a few seconds, maybe a few minutes, depending on your bandwidth. It should be fine. Yeah, it's done. Now that you have your dependency, you can see that there is a node modules folder inside the project directory. Do not touch that folder. You have all the dependencies needed for that project. Do not touch the node modules folder. What you have to do now is run npm run dev. And it should open in your browser, like this. Cool. If you have any troubles, you can simply join the Discord by clicking on the link on the top right corner and click members only, and you will have access to the Discord server, and we will try to help you as we can. Great, so in the setup, in the starter, all we have is the project, how we left it in the previous lesson, which means we have our cube. The camera is facing the cube. This is why all we can see is a square. It's because we can only see one face of the cube. And we can go further. So you can close the terminal. Because the server is running, if you refresh, it should be working. Great. Let's start with the easy part, how to move objects. And you probably already know how to do it. You can open the src script.js file, because all the code we are going to do today in this lesson is going to be inside that file. So if you do changes, like let's say I do a console.log hello3js, it refreshes, it reloads automatically, and I get my hello3js. You can actually let the DevTools open. You can access the DevTools by going to More Tools, Developer Tools, and go to the Console tab. So you can see if you're doing errors. Great, I remove the console and we can go further. So the first property is position. Position lets you move objects. You can do it on the camera as we did in one of the previous lessons, like this, but you can obviously do it on a mesh, because mesh inherit from object 3D. If I do something like mesh.position.y equal, let's say 1, you will see that the cube is moving on the top, upper. But what about those axes? It seems like X is going left and right, Y is going up and down, and Z is probably going forward and backward. This is true, but it's purely arbitrary, meaning that depending on the context, depending on the camera orientation, you can have a very different result. If my camera were like on the side and looking at the center of the scene, the X and Z axes would be different. And actually, if you are using other software like Unreal Engine, Blender, stuff like that, Unity, the axes might be different. Maybe the one going to the top is by default the Z axis. It's the case for Blender. So you have to adapt. In Three.js, we just consider by default that the Y axis is going upward, the X axis is going to your right, which is that way probably. I have to invert. And the Z axis is going to the back, meaning forward the camera. But this is all default. It's arbitrary. You can change those. You can play with the axis as you want. Okay, cool. So let's play a little with it. What I can do, oh yeah, another thing is, what is 1? 1 can be anything. 1 can be 1 meter, 1 centimeter, 1 millimeter, 1 kilometers. It's up to you. What I recommend is to decide. If you are building, let's say, a house, you can imagine that 1 is 1 meter, because it's going to be easier to imagine 1 meter. Like if you want to create a door is a little higher than me, so it's going to be like 2 meters, maybe a little more. If I'm going to put the roof, it's one flat, so it's going to be like something like, 3 meters above the ground. So it's easier if you decide that 1 is something like 1 meter. You can use feet, you can use inches if you want. If you're building, let's say, a huge landscape with mountains, stuff like that, you will probably decide that 1 is 1 kilometer. Just decide and stick to it. So yeah, let's play with it. I'm going to set those coordinates, 0.7. On the y, it's going to be minus 0.6. And on the z, it's going to be 1. I'm not saving. Just try to guess, looking at those numbers, where the cube is going to end. Just try to guess. Pause the video, because I'm going to try on my own to guess where the cube is going to be. And let's see if you are right. Me, I'm looking at this, x positive, I think it's going to be to the right. So for you, it's going to be this way. So on your right. Y is being negative, so it's going to go to the floor, down. And Z is being positive, so I think it might go forward the camera. And I might be wrong on this one. I save. It seems to be that. If I increase the Z, you get closer to the camera, which is not very clear right now, but that's the idea. If I put minus 3, yeah, it's going further away from the camera. So yeah, that's it. Great. Cool, so it's working. It's a good exercise. Just try to guess, put random number, maybe negative, maybe not, and try to guess where the cube will end. One more thing about changing those properties. You can do it anywhere, almost anywhere. Just look at this. I'm going to put it after adding the mesh to the scene. I get the same results. If I put it even further, after creating the camera, it's still working. And if I put it at the end of my code, it's not working anymore, because I did the render before moving the object. It's like taking a picture. If you say to your friend, move, and then you take the picture, you will see that your friend has moved. Great. But if you take the picture and you say move, and you go, somewhere else on the picture, oh, you didn't move in the picture. It's obvious because you ask him to move after taking the picture. So right now we are taking the picture with a renderer render, and then we are moving our mesh. So it's not logical. It's not an error. It's not a JavaScript error. It's not logical. Usually I put the position right after creating the object, and before adding it to the scene, because it's logical. But you can do as you want. And obviously you cannot do before creating the variable, because that's a JavaScript error. So I put it there, usually. All right. Position is not just an object. If you look at the documentation, you will see that position on Object 3D is actually a vector 3. A vector 3 is a class that you can use to position things in space. It's a vector. Maybe you've heard of vector. You can have vector 2, vector 3, vector 4, and probably even more, but in 3GS it's 2, 3, and 4. Vector 3 has more than just X, Y, and Z. It has a lot of methods, and you can see those methods in the documentation right here. You have a lot of methods available, and a lot of them will be too complicated right now, but we are going to use some of them just to discover for the moment. So yeah, let's discover one of them. I'm going to put some codes after adding the mesh to the scene. It can be right after changing the position, but I want to make some room. And I'm going to console log mesh.position, which is a vector 3, dot length. I'm going to call, it's a method, so don't forget the parentheses, length. I save, and as you can see, the length is 1.3601, so it's very precise. I get the length of the vector, which is kind of the distance between the center of the scene and our object's position. Cool, so you can get those results. If I move my object a little further, you'll see that the length is now bigger. The value is bigger. Cool, I will put it back somewhere like this. Yeah. So I have the length. Great. Let's see other methods, available methods. You have distance too. Okay, so the length gives you the distance between the position and the center of the scene. But what if you want to know the distance between, let's say, the camera and the object? I don't know why. Maybe one day you will need this. It's very useful actually for some experiences, stuff like that, to know the distance to the camera. To get the distance from the camera, you can use distance to, like this. And obviously you have to pass a parameter, which is another vector 3. So you can create one. You can do like new 3.vector3. But here, in our case, we want to know, I can imagine like 1, 0, 1, 2, something like this, great. But I want to know the distance between the object and the camera. So how do I get the position of the camera? Well, it's very simple. You just have to write camera.position. But we did a mistake here. If I save, you will see that there is an error, and you can read the error. Cannot access camera before initialization. So the problem is very simple. The camera is declared after. So we have to move this console log after creating the camera. And if I refresh, I have to do it manually because the live reloading crashed. I have the distance between the camera and the cube. And if I move the cube forward the camera, like this, you can see that the value is smaller because that's the distance between both of the objects. Cool, so this was distance 2. The next one is normalize. Yeah, this one is very interesting. We are just going to discover it without any real case, but you see that this one is very useful. It's called normalize. So I can get the console log back here. So just after creating the mesh, and I can call normalize. So I don't need to put it inside a console, which is dumb. Sorry, I put it there. So you can remove the console. When doing this, so it's going to be on nothing. So you just call mesh position normalize. I saved. And you can see that the cube moved. Normalize will take the vector length and reduce it so it's 1. So if your vector is, I don't know, very far over there, it can be x something, y something, z something. It will take the length of the vector and it will reduce the vector until the length is 1. This can be very useful, but we are not going to talk about those now. If I get like console log mesh position length, you will see that the length is going to be 1, obviously. Great. Is there another one? Oh yeah, the set. So I'm going to remove those because we don't need them. You have three properties, X, Y, and Z. What you can do is update all 3 at once. You do mesh position. Don't forget that position is a vector of 3, and you can call the set method. And the set method, you can pass all 3 properties in that order, X, Y, and Z. It's going to be 0.7, minus 0.6, and 1. And I can comment these, save, and as you can see, my cube is at the same place. I can toggle them, see? I'm using the old version, it's the same. So it's up to you. Maybe you want to, you prefer to change each axis separately. So you will be doing this. Or maybe you know you're going to change all 3 of them. So you'll be doing this. It's a little faster It takes less place to update, so it's up to you. Do as you want. There is no performance difference right here. Almost no performance difference. So yeah, let's move further. Positioning object in space, is pretty hard. Maybe you're good at it, maybe you're not. Anyway, I will show you a good solution to fix this. It's called the Axis Helper. It's a class inside 3GS that will create this. As you can see, I don't have the example right here in the documentation, but I have some examples I can click on. You can test those. I click on the second one, which is WebGL geometry convex. And this is just an example about convex geometries, but we don't care about this. What we care about is the axis helper, which is those strokes you can see right here. The green one, the red one, and the blue one. This is just an helper, so you can represent the axis visually, which can help us a lot. So let's create it, and you see what we get. To create the axis helper, I will put a comment, axis helper. I will create, axis helper, which is fine, equal new 3.axis helper. Careful with uppercase, lowercase. You have to do it right. I won't put any parameter right now. I will show you, you can put one, you can use one parameter. And don't forget that this is an object. So you have to add it to the scene. So I will do scene.add axis helper like this. I save, it reloaded, and as you can see that I have my axis visible here. Wait, where is the blue one? Well, it's very simple. The blue one is just a point because it's going like straight to us and we cannot see it because it's too small. Actually, you might see it, but it's very small. We're going to fix this. We can simply move the camera to be sure that this axis, the blue one, is here. To do that, you can simply move the camera, let's say, up and on the right. So it's going to be X1, Y1 and X1. I save, and as you can see, here is the blue one. So the red one, red orange one, is the X, positive X axis. The green one is positive Y axis, and the blue one is positive Z axis, obviously, which is great. You can use this, and the length is actually 1 unit. So I will put the camera back where it was, and you can change the length of each stroke by putting a number right here. If I put 3, we see that it's much longer. If I put 2, it's twice the original size, which is 2 units. So it can be very useful. We are not going to use it inside the following lessons, but it's up to you if you want, if you prefer, because you're having a bad time positioning objects in space, you can use it. So you'll be able to see that the x-axis is this one, the y, and the rest. Okay, cool. Next. So we learned how to position objects. Let's add a small comment so we can see it more clearly. So it was positioning. What I'm going to do is move the scene add here. So we have position, then scale, then rotation more clearly, something like this. Yeah. Let's play with the scale. Scale is going to be very easy because scale is also a vector 3, meaning that you can change, let's say, the scale on the Z axis. Now let's use the X axis. We're going to do mesh.scale. So we are going to scale, and because it's the X axis, so X, I want something like this in front of you. So it's horizontal. So it's supposed to be the red one, and the red one is the X. Cool. So let's change the X and do something like 2. And it did work. And we can change other things, like let's reduce on the Y, 0.5, and let's also reduce on the Z, 0.5. And if you're a maniac like me, you will do it in the right order, which is X, Y, and D. And we get something like this, which is just working as expected. Nothing to say here. The default is obviously 1. If you put 1 everywhere, you get something like this, which is the original cube. And because it's a vector of 3, you can change all properties at once by doing mesh scale set, and the set you will put 2, 0.5, 0.5. I can comment this one and I get the same result. So look at this. Previous one was giving me this, and using set, I get the same result. Okay, great. Now let's talk. Let's talk about rotation. We want to rotate the object. To do a rotation, it's a little harder because we have two ways of doing a rotation. You can use the rotation property or you can use the quaternion property. But why do we have two ways of doing it? We are going to start with the rotation and then talk about quaternion. The first thing you need to know is that updating one will automatically update the other, which is great. So you can use any of those two solutions, you will get the same result and then switch to the other solution and things will keep updating, which is very useful. Okay, let's start with rotation. So we have the property which is rotation. So you can access it by doing mesh rotation. Rotation also have X, Y, and Z. So you probably think that it's a vector free, but no, unfortunately, it's Euler. You can see Euler inside the 3 documentation by clicking on the link as always. And this is what's an Euler. It has much less methods available, but it's made to do rotation. Okay, this is why it's not vector free. We need something more appropriate to do rotations. So let's understand how to do a rotation. When you want to rotate your object, you first have to think like in what axis you're going to rotate it. Let's take an object. So I will take this tray. I don't know the word exactly. Palette. Imagine you want to do this. Okay. It's like you put, let's say, a stick through here that goes through your object inside the middle and you rotate like this. So it's that axis. It's the one going upward. And you know what axis is going upward. It's the y-axis. If you wanted to do something like, let's say you want to rotate like this, like a propeller. Like you're on a plane, you want to rotate the propeller. What's the axis? Well, imagine you put a stick through the object. So it's going to be that way. And you rotate on it. So you cannot do this because there is a stick going through, and you cannot do, so it's not this, so it's not, sorry, I lost myself. Well, anyway, you put a stick through it and you rotate like this. Well, it's the Z axis, okay? And if you want to do something, let's say the wheels, so it's on my side, I want to rotate like this because it's wheels. Just imagine that you're rotating wheels. Well, it's going to be the X axis. It's hard to imagine. You will probably get it wrong at first, but don't worry, you get used to it and you will understand the axis you have to choose for doing a rotation. So yeah, let's try this. We are going to increase the Y rotation. So I'm going to do mesh rotation, which is an Euler Y. And I don't know, let's start easy with 0.5. And if I update this, I get something. Let's put it back to 0, which is the default value. So I get my my cube, which is more like a box now. And if I do 0.5, it starts rotating. If I do a little more, let's say 1. Oh, it's rotating, okay. 1.5 maybe. Yeah, it's going further. 2. Okay. What if I want to do half a rotation? Let's go to half a rotation. I will put 3. It's almost there. Almost, maybe 3.1. Yeah, it's getting close. 3.12. Yeah, it's very close. Maybe you know where I'm going right now. The good value is something like this. And you probably saw this number already. This is pi. You know about pi. Remember, it's basic mathematics. So you have to remember those things. Don't worry, I'm showing them to you so you can remember. This is pi. Pi is, I won't go into details, mathematical details. I'm not even good at mathematics. Pi is like a number that helps you do half a rotation. If you want to do like full rotation, it's going to be 2 times pi. So how do we get pi? We can write it like this. Okay, this is all I know about pi decimals. Or you can use math.pi, which is pure JavaScript, and you get an approximation of pi. And if you write it here, like math.pi inside the console, you can see that we have a pretty good approximation of pi. Great, if I want to do like, let's say, a quarter of a full revolution, it's going to be math pi multiplied by 0.5. Or divided by 2, it's the same. Nice. It was just an example. So let's play a little, and you can do like rotation on the x. It's going to be pi 0.25, and on the y, pi 0.25, and we get something like this. Cool, we are rotating our object just like this, and we could also move the z-axis. You have to be careful with rotation. You might have a problem. The problem is about axis, rotation axis order. When you are moving on let's say the x like this, the y was going upward, okay? But if you move the x and you change the rotation, the y is not going upward like before. The y is going this way. If you move entirely like this and you now rotate the y, it's not going to do that. It's going to do like this because you change the y. So you have to be very careful about this, and you can have very strange results. One of those strange results is when you get lock, meaning that you have one axis that gets just lock. You cannot change this axis. This is called gimbal lock. It can happen too, and you do a lot of rotation, and suddenly it's like one axis is not working anymore. You don't know why. It's simply because you stuck this axis, and it's a gimbal lock. So how can you do to fix that? First, you can change the order. Changing the order, meaning that instead of applying the X rotation, then the Y rotation, then the Z rotation, you apply the order you want. If you are building, let's say, an FPS game, you will need to change those because you want the rotation to do first like this, which is the Y. So you want your player, if the player moves the mouse to the left, it does something like this. And then if the player moves the mouse down, you get something like this. So you apply first the Y and then the X. And if you don't do that, you get X and then Y. And as you can see, my head is not looking like the horizon, so you will have a problem. If you want to create a FPS game, you have to say to 3GS to do Y and then X and then V, but we don't care about the Z because we can do without it. So how to do it? It's pretty simple. What you have to do is mesh rotation and call the reorder method. And here you will write the axes in uppercase in a string. And we put Y, X, Z. And if I save here, as you can see, my object is not at the same position. The rotation did change because he did first the Y and then the X, which is different. Yeah, it's kind of hard. Don't worry. We don't need much of that. I just want to warn you about this. If at a point you get this problem, you will remember this lesson and you will say, ah yeah, no, it's about axis order. This is the important part. Another things, doing the reorder after, we just get the previous result. So you have to reorder and then change the axis. And calling the X and the Y or the Y and the X doesn't change anything. As you can see here is my cube. And if I change the order between Y and X, it's the same result, okay? The important thing is to do reorder before before changing the rotation. Nice. Let's go further. So yeah, about Euler. As you can see, this other things problem might be very problematic. One solution many software are using is quaternion. And this is why we need quaternion. Quaternion is like a representation of rotation, but in a more mathematical ways. You can get the same result, but using different formulas, different axes, it's very different calculations, but at the end, it resolves a lot of problems. The difficulty with quaternion is that it's hard to imagine. When we had the Euler, it's like putting a stick through the object. It's okay, we can understand this. Quaternion is a lot harder. I won't be able to explain to you how quaternion works because it's a huge subject and I'm not too much into mathematics. But just remember that when you update rotation, it updates quaternion. And when you update quaternions, it updates rotation. And sometimes you will get coordinates that are in quaternion, and you will just apply this quaternion to the object quaternion. You don't have to understand the exact angle, you just take the quaternion you'll be provided and apply it to your object quaternion, and the rotation will be updated and the object will be rotating the right way, which is pretty easy. Okay, next is about looking at something. One very cool feature is that you can tell any object 3D to look at something. Let's say you want your camera to look at the cube. So as you can see, my camera right now is looking at the center of the scene because it's the default position. We created the camera, we moved the camera backwards, so now it's just facing the center of the scene. What if I want my camera to look at the cube, but exactly at the center of the cube? Do I need to do like complex calculations with mathematics, trigonometry, stuff like that? As I told you, I'm not very good at mathematics. Maybe I have another solution, which is obviously look at. So look at, it's very easy to use. I'm going to do it on the camera. And what I need to do is camera look at. So it's not on the rotation or the position or stuff like that. It's directly on the object 3D. So it's my camera. And it works with every object. It will orientate the object so that it's minus the axis is facing the target. Okay, so it will just look at the object. And what you need to provide here is a vector 3. So you have to give him coordinates. If I can create a vector 3, I can do new 3.vector 3 like this. And I can put 0, 0, 0, which means it's looking at the center of the scene, which is not very useful because it's the same, so it's useless. But I can change it and do something like 3 on the X. So as you can see, this is the center of the scene. This is my axis helper, which is at the center of the scene. And now my camera is looking on the right. What I can do, instead of trying to guess where the object is I can use the position of the object, which is a vector 3. So I can do mesh.position. Remember that this is a vector 3, which is the position of the cube. If I save, my camera is looking straight at my cube, which is a box, and I had nothing to do, no calculation. Just look at this position, this vector 3, and my camera rotated. Great, we are going to use this one quite a lot. Okay, finally, combining transformations is as easy as we did until now. You can do it like in any order. Just look at this. I'm going to take the position and put it after the rotation, and it's the same result. You just change those properties. It's like a state. You say, this is your rotation, this is your position, this is your scale. And at the moment of the render, you will be able to see the result. And that's all. You don't need to care about the order. You can use set, or you can use the long version. It's up to you. One last thing, sorry, there was one missing. It's about scene graph. Sometimes you will create complex objects. Let's imagine you're creating a house. You will create walls, doors, windows, bushes, a garden, stuff like that. And at a point you realize that, oh no, it's too small, or maybe it's not at the right place. What are you going to do? You're going to move each element, so the bushes, so the walls, so the door, and it will be a mess. It will take hours to move everything. What you can do is create a group and put everything inside that group. And you probably guessed it, a group inherit from object 3D, which means that you can move the whole group, you can scale the group, you can rotate the group. So if you're creating, let's say, a spaceship, you will create a lot of parts, put those parts inside a spaceship group, and then you will just move the whole group and do animation with the Star Wars things, stuff like that. So it's very useful. Have this habit of putting things inside groups, so that if you want to move the whole group, you can. So yeah, we are going to do this. We are going to create, so I'm going to remove my cube, just like this. Because I removed the cube in the object parts, all I have is the axis helper. If I save right now, I'm going to have an error, which is because I'm telling my camera to look at the mesh. So I'm going to remove the look at too. Okay, what we are going to do is create one group with 3 cubes inside that group at different positions, and then rotate the whole group. In later lesson, we are going to create a house, things like this, so it's going to be a lot more interesting. But for now, we are just going to create 3 groups. So let's start. First, I have to create the group. So you do group. Obviously, you can call it like spaceship or house, but here is just a group for the example, so I'm going to use group. I'm going to do new 3.group because this is the class we need. You can see the documentation right here with example. Very similar example, actually. Okay, so I created the group. Don't forget to add the group to the scene. Okay, you do scene, add group. If you don't add the group to the scene, you won't be able to see anything. I refresh, I have nothing but my axis helper because my group is empty. The group is totally empty unless you add things inside. So let's create those 3 cubes. We are going to do things a little differently this time. We are going to create the mesh directly. We are going to do cube 1 and create the mesh, 3.mesh. So I'm kind of forgetting to create the geometry first and then the material. I'm directly creating the mesh. What I can do is instantiate the geometry inside the mesh instantiation. It's another way of doing the same thing. Same thing. 3 box geometry, and I'm going to use 1, 1, 1, which is the size, comma, new, so we can see much with all those helpers, mesh basic material, like this. And don't forget, we can write like a color, 0x ff 0000, and you get your mesh composed of 1 geometry and 1 mesh basic material. Oh, sorry, mesh basic material, like this. I did a mistake, my bad. So yeah, cool. Now we are going to add our cube, but we are not going to add the cube to the scene. We are going to add it to the group. To do that, you do group, add, cube 1, and that's all. We have the same result, but the cube is now inside the group and the group is inside the scene. Let's create 2 more cubes, sorry. I'm going to create a cube 2, so I'm going to duplicate this whole part, so the instantiation of the mesh and the add part. I'm going to call it cube 2. You can change the color if you want. Let's use another one, like this. So we have both cubes at the same place. Try to move the cube to the left and get back to the video. I'm going to show the solution. It's going to be cube 2 dot position dot x equal positive, negative, I don't know, I think it's negative. I'm going to use -2, and yeah, it's on the left. Cool. I update all this part, So the cube 2 with the position and the add to the group. And I'm going to call it cube 3. Use another color like this, just to see the difference. And I'm not going to use -2, but +2. So I don't have to write plus, I can just remove the minus. And I get something like this. Nice. And you probably know where this is going. We are going to move the whole group. Let's say group position, because we have access to those properties, y equal 1. And the whole group went up. If I do scale y, let's say 2, we stretch the whole group. And if I do a rotation, on the y-axis again, why not? I'm going to use, I don't know, 1. The whole group did a rotation. And I can start to build like a full city, and then the city starts moving in the sky or stuff like that. Very useful. Great. All right. We now know how to transform objects. In the next lesson, we are going to know how to animate things finally.